Hi, I'm Brendan Smith, co-founder and CEO of SiTration, and we are building an ultra-efficient process for recovering critical materials in lithium-ion battery recycling. This is such a critical mission because critical materials really enable global electrification. And without global electrification, we're not going to be able to reduce CO2 emissions over 40% by 2050, which is the full potential of that process. The good news is electrification is already happening today, but the bad news is we might not have enough critical materials to build the batteries that we so desperately need to make this transition possible. These materials chiefly are lithium, nickel, and cobalt. And lithium, of course, is foundational for the battery chemistry, but the supply chain is far from stable. This is highlighted by a 400% increase in the spot price of lithium carbonate about a year ago over only a few months span. So what this really tells us is that we not only need to bolster the supply chain of primary materials that we're mining from the ground, we also need to do a whole lot of work on the battery recycling side to reclaim these materials from end-of-life batteries. And fewer than 10% of all lithium-ion batteries are actually recycled today, so a pretty egregious figure. SiTration is disrupting this picture by developing an ultra-low-cost and ultra-sustainable process for doing this relative to the status quo. We do this via a patented silicon-based filtration membrane and a unique extraction module that we invented here at MIT about 5 years ago. What this enables for us is a process that we call smart membrane filtration. The membrane itself is actually electronically conductive, and so we can drive a current or a voltage through this membrane. And actually, by turning a knob with a single piece of membrane material, we can allow different things to pass through or reject them to flow downstream. So for example, here in the center, we can actually turn a knob to a certain location and allow the orange material, say lithium, to be extracted from a complex mixture. For that same membrane, we turn the knob once more to a different location, and now only the green material can flow through, say cobalt. By doing this, we can take an extremely complex dissolved battery mixture and extract with ultra-high selectivity and efficiency the most important and valuable chemicals to then be reused right away in the battery manufacturing chain. So if you zoom out to the broader picture, we can plug into the existing battery recycling process. We can do so with about 5 times fewer steps required, and we can drastically reduce the amount of chemical and energetic inputs that are also going into the process. Our goal here is really up to about 10x less chemical and thermal energy consumption, and an operating cost about half that of the current status quo process today. To tell you a bit more about how this actually works, we can take a single SiTration membrane and break it in half and look with a microscope at that cross-section. So this is exactly that, using an electron microscope. From top to bottom of this slide is about 0.5 millimeter in thickness. If you look really closely, you can actually see the vertical pores, those gray streaks running from top to bottom, passing all the way through that material with nanometer scale thickness. What you can't see here is that this membrane specifically was actually used to extract nickel from an extremely complex dissolved battery mixture. But using a different microscope, we can actually see nickel, well, lighting's not so great. We can see nickel in red here actually indicated throughout the membrane as it's been pulled out of that solution as it passes through the material. The final step here is to harvest that nickel into a pure solution and convert it back to a solid chemical that then goes into a new battery. So this can be an ultra-efficient process. So of course, this work would not be possible without the amazing support of E14. We're extremely grateful for that and our other investors as well. What this support has enabled since the company's founding in 2020 is the expansion of a team to 5 full-time personnel that's continuing to grow. We're expanding our IP portfolio at a very significant rate. And excitingly, we're currently negotiating a multi-million-dollar project with an international partner to take this technology to the small-scale pilot stage within the next year or two. So I want to thank you all for your time and attention. I look forward to talking to you. I want to say that if you agree with us that critical materials are absolutely vital for all of our future, please join us in this mission. Thank you.